Hello, my name is Tommy, and today we're talking about redox titrations. So, an acidified solution of 0.135 molar potassium permanganate is titrated into a 50.0 milliliter solution of sodium oxalate of unknown concentration. 14.56 milliliters of 0.135 molar potassium permanganate is required to reach equivalence point. With the following half reactions, what is the original concentration of oxalate? So we have our reduction and oxidation reactions. So what we want to do is we want to multiply each of these by a factor of something so that we can get these electrons to cancel each other out. So what we have to do is we have to multiply our reduction equation by 2 and multiply our oxidation by 5 so that we get 10 electrons on each side. So our final equation would be 16H plus 2 permanganate plus 5 oxalate yields 2 manganese plus 8 H2O plus 10 carbon dioxide. Now that we have this, we can calculate the amount of moles of permanganate. So we have 0.135 molar of permanganate, and then we multiply this by 0.01456 liters of, permanganate, because molar, remember, is moles over liters. So if we multiply by liters, we get moles of permanganate, which is 0.00197 mole permanganate. Now that we know the amount of permanganate, or the amount of moles of permanganate at the equivalence point, we can multiply this number by permanganate. You multiply this by 5 oxalate per 2 permanganate, and that gives us 0.00491 mole oxalate. And we're able to use this mole ratio from our equation that we got from our reduction and oxidation reactions. So now that we have the moles of C2O4, we can finally figure out our concentration by dividing by the 50 milliliters from the beginning. Except we gotta convert that to liters, which is 0.05 milliliters. So 0.00491 mole C2O4 minus 2 over 0.0500 liters. And that gives us 0.0983 molar C2O4.